My name is Srikanth Madala. I'm from the Department of Mechanical Engineering, College of Engineering. My advisor is Dr. Bean. I'm going to present to you today a little bit about the energy future of the country. So in order to understand the future, first we need to understand the present. So today, if we look at the energy consumption of US, if we divide the energy consumption, a large percentage of our energy consumption comes from fossil fuels. If you look at the chart here, you see that almost 36% of our energy consumption comes from petroleum, 29% from natural gas, 16% from coal. That's a total of 81% from fossil fuels. The most hyped about solar energy or wind energy, the renewable energy contribution is only 10%. Among that 10%, the widely discussed solar energy is only 6% of that 10%, which is only a 0.6% of our energy consumption. So solar energy, although it is a widely discussed topic around, is only contributing 0.6% of our energy consumption overall. We are still a largely fossil fuel dependent economy. I think for a good future, that needs to change. The reason that needs to change is because of this. I'm showing you a solar potential of the desert southwest here. So if we look at the region, the desert southwest is deeply red. We are bestowed with solar radiation. If you look at this small region I marked here, that is how much region we need to cover with solar panels to generate the electricity for the whole nation. I'm not asking to do that, but even if we partially do, if we partially achieve that task, we will be able to produce surplus amount of electricity for not only these desert southwest states, but beyond those states. So this region I showed you, the radiation can be largely used for concentration purposes. So now coming to what is concentration. When we focus solar radiation that is incident on a larger area into a smaller area, we can generate a greater power out of it. So for example, as a kid, we might have all played with the magnifying glass to burn something, right? So that's a basic example of a solar concentrator. In history, it is believed that Archimedes used solar concentration to prevent the invading Roman ships. So he used the bronze shields of the soldiers to focus onto the invading Roman ships and burning their sails. So that is history. So what is it today? Solar concentration today, we can generate power out of it. We have almost a 34% of conversion efficiency using highly concentrated panels. We can use solar thermal power stations like these, where a mirror field is concentrating the energy onto the central tower, and where that energy at the central tower can be used to run turbines and generate electricity. So now with all these technologies you saw so far, we are always tracking the sun. So sun tracking is important for all these technologies to work. But sun tracking is also an energy consuming technology. So that means it also consumes certain amount of energy that is generated. Additionally, the cost in the system increases by 25% because you are tracking the sun. So my research goal is to design a stationary concentrator to do the same kind of solar concentration. Maybe you could get a little lesser, but you are saving a lot on investment cost. So to achieve that, we tried different computer models of designing solar concentrators. I'm showing you some of the solar concentrator designs which we tried, and the first one is a V-trough, the second one is a compound parabolic concentrator. I'm showing you two more designs here, compound elliptical concentrator, a compound hyperbolic concentrator. So you see the rays, so you can see the red rays are coming from the left and entering these concentrators and focusing at the bottom absorber plate. So the goal of these concentrators is to focus on the absorber plate at the bottom and generate electricity. So if we compare these to the already existing designs, the new designs we tried have increased a substantial amount of solar energy collection. So almost 65 to 80% of energy collection increase is seen with these new designs. So now coming to the question, it's all good, we can use stationary concentrators. Where can we use them? So coming to the application of stationary concentrators, they can be integrated into buildings. The reason they can be integrated into buildings, because these concentrators don't move. That means it can be integrated into anything that is stationary. So building integration is a great application. Integrating into walls, windows, doors and roofs as such would be a great application. Also, we know that 39% of the energy consumption in the US is through buildings. So if we can integrate some of these technologies into buildings, we could save on that energy. So I'm showing you an example here where you could integrate such technology into a building. Let's assume this as a wall where the solar radiation is coming from the left and entering the wall and focusing on the bottom absorber plate in the black. So if those are solar cells, those cells can generate electricity which can be used indoors. So in conclusion, I would like to conclude by saying that all the presidential candidates need to put more emphasis on a renewable energy future, and also we should emulate models of European countries like Germany by giving more incentives and rebates on renewable energy technologies like solar, wind and so on. Finally, I would like to quote my favorite quotation here. We do not inherit Earth from our ancestors, but we borrow it from our children. So for the sustainable energy future, we need to save, we need to invest more on these future technologies to give them a bright future. I would like to thank you for paying attention, and also I would like to thank my advisor for supporting me all through this research. Thank you very much.